So now we are going to have an experiment where I will show you that KMnO4, which is one of the great oxidizing agent, how that actually changes color in presence of a reducing agent in alkaline medium. In order to do that, what we need definitely potassium permanganate, okay, and we need for as a reducing agent we need the dextrose solution, which is glucose, and to maintain the alkalinity of the medium we need sodium hydroxide. Now we have already here added sodium hydroxide solution and glucose I have already added, and you can see interestingly the solution has turned yellow. Now in the comment box, I want all of you to comment that why when adding glucose in sodium hydroxide the solution turned yellow. Definitely there is a reaction going on. In the comment section write about that reaction. Okay, now see what I will take at the first step. We will take a small amount of potassium permanganate in the conical flask. Now taking it a very small amount, very small amount. Now we will add water. Okay. Now you can see the color of the solution is purple. Okay. Now, very carefully, if you notice, very carefully, if you notice, now what I will do, I will put a in order to check the color change. Okay, now let's add that solution. You can see the color of the solution has turned green. So this is in manganese in +6 oxidation state. Okay, now slowly the green color is getting faded. If you add the glucose solution more, the solution has turned red. This is manganese in +4 oxidation state, and you can see that this, if you add even more amount of the alkaline glucose solution, the solution will remain in +4 oxidation state. That is, so what it suggests? It suggests that in alkaline medium, the KMnO4 changes the color from violet to the green to the red. That is the oxidation state +7 to +6 to +4. Whereas in acid medium, it changes from +7 to direct to +2. And if you want to see that video, you just check the link description of this video. Okay, so both the states of manganese in KMnO4 changes differently in different medium, and how it is we will see in a while.
Hello. So what we just saw, we saw that in presence of glucose in alkaline medium, the KMnO4 minus changes its color from violet to green to red. Now see, this reaction is also called the chemical traffic light reaction. Okay, now let's see what actually happens during this course of reaction. Okay, so first what we took the KMnO4 minus, okay, where the manganese is in +7 oxidation state, right? Now as a reducing agent in alkaline medium, what we took glucose molecule. Okay, now let's write the structure. The structure will be better. Okay, CH2 OH H. Okay, now if you see here very carefully, in glucose, this aldehyde group is a reducing group, and in previous video of detection of carbohydrate, where we also told you that this glucose, this reducing group, that is CHO, it actually works as a reducing agent in alkaline medium. Okay, so what is happening in presence of alkali, the reaction, okay, in presence of alkali, the reaction, particularly this MnO4 minus, at the first step, it is converted into MnO4 2 minus, and in this particular molecule, your manganese is in 6 plus oxidation state, and the color of this molecule, color of this solution, what we saw is basically your green. Okay, so finally, so what happened in this first case? This changes from violet to green, what we saw. Now further reduction by the glucose molecule, again what happens, this MnO4 minus has changed its color to Mn4 plus. Now this Mn4 plus, what we saw, that is basically your red in color. So now I think you can understand why it's called chemical traffic light, because in traffic light what we see, green, red, green is for the go, red is to stop, right? So here also the KMnO4 in this alkaline medium in presence of glucose, it is also showing that kind of observation. Okay, now you literally thinking that what happens to the glucose? Nothing. Simply, as a standard reducing agent, what a reducing agent does, it actually gets oxidized. So as a standard reducing agent, this glucose molecule will also get oxidized, and what will happen to him? In both cases, this reducible group, that is the CHO, that will be converted into the acid, and since it's alkaline medium, so it will be a salt. So let's see what the structure becomes. Okay, so CH2OH and COOH. So what happens here, if you can see here very clearly, the aldehyde group, now in presence of oxidizing agent MnO4 minus, it is converted into the acid group. Okay, and it cannot stay as an acid because it is basically a alkaline medium, so it will be COONA minus Na plus, so it will be stay as a salt. Okay, so I hope you like this series of experiments which we are doing here, and hopefully in the future we will do more and more experiments and the more and more explanations, and these kind of experimental things and this explanation will help you in the qualitative and the quantitative analysis part, which from there many questions comes in the NEET examination. Okay, so if you like this video, please like, share with your friends and subscribe our channel, and if you have any queries or any doubt, don't forget to comment on the comment section. Okay, thank you everyone.